session. I'm sorry, I won't call you out. Okay. Talk about routed fast convergence. So let's just do a quick thing on who I am. So my name is Denise Fishburne. You can call me Fish. Dual CCIE, CCDE 2019-14. And I have been with Cisco since 1996 in TAC and then Advanced Services, and now in what is called the CPOC, the Customer Proof of Concept Lab. Who is familiar with the CPOC? Wow. That's a lot more than any of my other classes. So the CPOC is a Customer Proof of Concept Lab. We don't necessarily market to you, the customers. We actually are a service that is free for your SEs. So you're not allowed to show up without them because it has to be, we need some skin in the game from them. So we are a small team, and what we do basically is so I'm kind of sort of a jack of all routing things. I would say that I'm only a master in troubleshooting. So I do refer to myself only as a subject matter expert in troubleshooting. My specialties, of course, are anything having to do with routing, switching, MPLS, inter-AS, yada, yada, yada. And now, and DVPN, blah, 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 blah. So that's my world. That's the world that I play in. That's the world that I live in. So with the CPOC, the Customer Proof of Concept Lab, it's a 3-week cycle. The first week is what we tend to refer to as pre-setup week, or what I call the week with the 4 Cs. So you take the chassis, you get the cards off the shelves, you put them in, you load code, you do cables. And then the next week is setup week. Hopefully by Wednesday at 2 p.m., we are configured, we put the 5th C in, we are configured and we're into testing. So hopefully by Wednesday at 2 p.m. we're testing what we're going to show to you when you come on site or via telepresence for 5 days the next week. So you can see how that math doesn't quite work. So we do I see a lot of you all coming through doing, trying to get to fast convergence, trying to get to sub-second convergence. So that's what we're going to talk about today. Did I say anything else about myself that I'm supposed to say? Whatever. Did I say CPOC since 2001? Okay, there you go. Let's just do a quick spoiler alert. We're going to do a quick spoiler alert, and I'm going to actually ask you all a question. So, spoiler alert of what we're going to talk about today, or what some of the things are that I want you to leave in your mind. And we're going to work backwards from hopefully having these ideas solidify in your mind. So designing for fast convergence is more than just tuning timers. It is a design. I want you to think about network convergence, not just routing protocol convergence. What do I mean by that? I mean end-to-end, not just your routing, your layer 1, your layer 2, the kinds of cables you're running. All of that stuff is actually going to go in because convergence really is end-to-end, the application that's actually riding on top of your network, and how quickly that converges in the time frame, hopefully, that your application wants, and how to get that to happen. Because whatever the weakest link is going to be felt. So I'm going to say, look at layer 1 and layer 2 for failure detection properties, and also do you have shared risk groups? So what would a shared risk group be? So an easy analogy would be if you actually look at how many people have 6500s? Okay, we'll just go ahead and take that platform then. So let's think of a line card that actually has 48 ports, and you are thinking of single point of failure. You don't want to have 2 line cards in there to do ether channel to these 2 guys over here. So you only really have enough money for 1. So you're going to go ahead and you're going to go with 1, and then on top of that, you end up putting both onto ports that go back to the same ASIC. So same line card, same ASIC. So when you have a failure, it impacts what you view as both of your redundancies. Now that's fine if that's what you can do, and that is what the management and policy and the budget, which we all do admittedly get constrained by. We are all doing more and more with less and less these days. I'm 50 years old. I've been in this industry since I started programming Fortran over 30 years ago. But did you laugh at the Fortran thing? Fortran. He's like, what's that? It's a transformer. That's what it is, yeah. It's the younger generation. So, it's interesting because we're all doing more and more with less and less, and yet the rate of change in our environment is very fast-paced right now. The other challenge that all of you are being tasked with is so much critical information is going on top of our networks. That didn't happen before. For those of you who just heard me speak at my other session, something that really, really brought to mind was I had a hospital come through in the past year, and they had a network outage. And the anesthesiologist was doing something. There was anesthesiology doing a study that was actually going over the internet, over their intranet. So during surgeries, during whatever. Now, they kiddingly, and I would assume that when it's this serious, you have to decompress somehow. They were like, we're really glad we didn't lose anyone. And that just kind of sort of brings the packet to a whole nother level. So we're going to also kind of sort of talk about what's being put on your shoulders, and also design decisions about, do you need fast convergence, and are you willing to take the trade-off for it? Because there's a trade-off, right? What's the trade-off? You go super, super, super fast. What's the trade-off? False positives. Stability. False positives. Okay? So I'm not going to say that going fast is what you should just come in here and just go do. I'm going to say do it for your critical traffic. What is your critical traffic? Apparently, I shouldn't get too close to something. I'm hearing noises, so I'm going to go ahead and not walk in the middle like I usually do. So sorry about that. I'll miss you. So failure detection is key to fast convergence, right? You can't react or do anything until you realize that there has been a failure. And it's very interesting because I'll see people tune timers down really aggressively, but then do other things like having switches in between. So not necessarily thinking about the whole network. So quick question, who runs OSPF? Who runs OSPF with iOS or iOS XE? Okay. Of you all, so real quick, of those people, I'm just curious because of some things I told you I was going to ask you some questions. So if you're running iOS or iOS XE and you're doing OSPF, have you left the timers, the LSA timers and the SPF timers on default? If you don't know what I'm talking about, go ahead and raise your hand also, because that means you left them on default. I don't know. You can see that hesitancy, So we're going to talk about that. So for you all, there is something that is going to be something that you can grab that I'm going to tell you. Go ahead and grab and run with it. So if you're running OSPF and you're running iOS or iOS XE, there's going to be something really huge in here that you can run back and you can modify today, in my opinion, without necessarily having the risk of false positives. Yes, sir?
Are you going to talk about LDP as well?
The question is, am I going to talk? Some people might say they have never seen me move so fast. Well, actually, yeah, and now I'm having PTSD about LDP, about even saying the word. So no, we're not going to. No, I'm not going to be talking about LDP in this. We'll talk about, so yes, you can use MPLS LDP. We can talk afterwards. A lot of people don't do that because it's an additional layer of complexity. I'm sorry? I think it's a wicked link in the iOS, right? So you got OSPF, ISF looking fine, but LDP broken, then well, absolutely. So of course, the question is, am I going to talk about LDP also? Because if you have an environment, LDP, for those of you who might not be as familiar with what he's talking about, is label distribution protocol, which would be viewed as MPLS, multi-protocol label switching. So the concept, of course, is, yes, Absolutely. What happens is that your IGP, so MPLS, and there's a lot of things that I'm going to say ride high on the food chain. So MPLS, LDP, in my opinion, is like multicast or BGP or every overlay that you are running right now. It runs on top of your IGP. Okay, so your IGP needing to be more solidified is becoming more and more important, especially as you're doing your overlays. Your overlays, of course, are a nice little programmed lie, right? So, and so the thing is that I do kid. I'm not kidding, but I do kiddingly say, is that all virtualization is a lie, and you have to make sure when you're troubleshooting that everyone actually keeps their stories straight. So, right, so your virtualization, some kind of overlay is going to go on top so it becomes more solidified. We can talk afterwards about that, but no, I was not going to go into that. The question, of course, is that if your multi-protocol label switching actually technically rides on top of your IGP, then how do they relate? Because you can have an environment where your labels actually have you going someplace where your routing is not ready. But no, we're not going to talk about that today. EIGRP, who's running EIGRP? When I was new to, and Donnie's going to kick my butt, in the back of the room is what I kiddingly refer to as one of the dons of EIGRP. So EIGRP originally had, pretty wave, princess wave. So Donnie Savage, Don Slice, and Donald Sharp years ago were right in the floor above me in CPOC. And they were doing EIGRP programming, visions, thinking. It was just incredible. So I will say that when I first came to Cisco, please understand, when I first came to Cisco in 1996, all of us start somewhere and we're new. I didn't know what an IP address was. Ask me whatever you want about SNA, LU 6.2. Ask me whatever you want about SNA. But I didn't know what an IP address was, so this whole VLSM, CIDR, blah, 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 blah. So to me, EIGRP was super simple, easy, and I've seen you all go through this. So how many people are running EIGRP again? Okay, so EIGRP I thought was super, super, super simple, easy. I thought it was the easiest one because honestly, we don't force you to think. I didn't realize that till later on. We don't force you to think. You do router EIGRP network and you're good to go. Okay? We don't force you to bound your query domain. We don't force you to have a good design. With OSPF, you're at least a little bit intimidated with OSPF. I'm not going that way. You're at least a little bit intimidated with OSPF because you actually have to figure out areas. Or you have to say, yes, I actually did design everything to be in area 0. Right? So I was like, ooh, EIGRP, because I don't really understand failure domains and all this other stuff first. So I loved EIGRP. So with EIGRP, how many people know who's running EIGRP about bounding your query domains? Okay, so for the people running EIGRP, we're going to go ahead and we're going to talk about that because EIGRP is wonderful, but we don't force you. We almost make it too easy for you to put in and allow yourself to just have this unbounded query domain because, you know, you're big boys and girls and rock on, we trust, go. When designing for fast convergence, the business needs are the driving factor. How many know about the CCDE? So the CCDE is a Cisco Certified Design Expert. The concept is that the minimally qualified candidate actually is supposed to be tasked at being kind of sort of like a design consultant. So from that perspective, everything should work backwards from the business needs. So I should be able to hear what your business needs are, and I should be able to hear basically that for whatever reason, this firewall doesn't support MPLS. So I mean, like I'd love to put some kind of MPLS thing through here, and then I pick that, and it's like, oh yeah, I would do this, and then I get this little email thing that says, on the next question, oh, well, this firewall doesn't support MPLS, so now we're back to the drawing board, because we don't necessarily get greenfield. So from a CCDE design perspective, I am going to say that one of the things I really like about this book, and I really like, is we have so much stuff on our network. So here's my question for you. What is the critical traffic? Okay, what is the critical traffic? Why do you need sub-second? Why are you here? Why are you trying to go to faster convergence? What is the business driver for it? Because whatever the business driver for it better be pretty good for you to deal with false positives or churn. So this is what we're going to do today. We're going to think about fast convergence. So we're going to get into the mindset of fast convergence. We're going to talk about routed convergence, failure detection, OSPF, ISIS. I'm going to kind of sort of lump those two together because there are things. And how many people is running ISIS? Yeah, okay, yeah, I'm sorry. You don't get tons of love in this session. So, so that's the typical. So if you have any ISIS specific questions, please feel free to come up to me or Donnie afterwards. Donnie just changed jobs a little while ago, but he was the routing technical marketing engineer for all of IGPs for all of Cisco. So he's pretty smart. So if you have any questions specific about ISIS, please feel free to come up afterwards. But I am going to go ahead and lump them together as kind of sort of similar in what they do and how they think and how they work. EIGRP, BGP. Who is running BGP? Okay, now, with those people who have their hands up, who is running BGP with inside of your environment and not just to your service provider? Okay, good. So, and then we're going to do some additional routed convergence. Who has actually played with BGP PIC? BGP what? Right. Okay. So I'm going to wave at it just because of the fact that it's been out there for a while. I don't see a lot of people rushing to it, so I'm just going to kind of wave at it here. One other thing is, who has heard about LFA, like OSPF, LFA? Yeah, okay, we're going to do a wave at that too. So good. So I'm on target. And then NSF, NSR. I'm a lab rat with a lot of really big equipment. And then I come here and I find that some of you don't necessarily have these really big toys. So I'm going to ask, how many people are familiar with NSF Graceful Restart? Okay, good. How many people are familiar with NSR? Okay. How many people have ASR 9Ks? Okay, so I am going to go ahead and talk about NSR because I think it's pretty cool, and that's pretty much, if you think of the ASR 9K, it's very much a service provider type box. So some of the, well, I'm not going to get ahead of myself. Fast convergence mindset, 200 milliseconds or less. Now, Sonnet actually has the bar really, really low, but it's not fair to say that Sonnet converges faster because that's only a layer 1 detection. So typically, when I hear people want to do fast convergence, what I'm typically hearing is I want sub-second, I want 200 or less. Okay, I want 200 milliseconds or less. I am going to ask you first and foremost, do you need it? Okay? Because if you don't need it, because it is admittedly a lot of thinking, a lot of designing, and a lot of tuning. So the first question is, do you need it? Of course I do. It's fast. It's shiny. So for you, what is the complexity of putting fast convergence into your network? Okay, I can probably go here. What is the complexity of doing fast convergence in your network, and what is the return? I am hugely, hugely, hugely an ROI person, right? What is the return that we're going to get out of the investment? We're all doing more with less. What is the return? Is it an immediate turn? Is it a 6 months from now return? Is it a proactive return? We know we're going to start actually having more critical stuff on here. So before we put the critical apps on, your hospital environment, whatever, before we put the critical apps on, we would like to go ahead and start having fast convergence before we pull the applications in. What are the business drivers? There are risks. You're going to have, if you actually have a lot of, so if you, like, anyone do BFD? So bidirectional forwarding detection, we're going to get into this. If you actually make this too low for your links, then you're going to have, I'm down. Oh, I'm up. Oh, I'm down. Okay? So it's a level of patience, and it's a level of patience for your application or your business needs. We all have learned, so if you call me and I pick up the phone, oh, I'm not going to pick up the phone from you. Okay, if you call me and I pick up the phone and you say hello and you hear background noise, then you kind of sort of figure the call has gone through. Maybe I'm eating something. Maybe, I just woke up. So you're going to have a patience level, right? As opposed to if you tune those timers down really low, then if I don't say hello right after you say hello, you're going to hang up. And then the question just is this simple. Is that what you want? So that's what I'm talking about. I'm talking about, hi. Hi. Should he have hung up already? Okay? So that's what I want you to think about. I want you to think about the risks. I want you to think about the business drivers. It's more than tuning timers. It's your processes. It's your monitoring. It's your applications. What do I mean by this? Can your network monitoring tools keep up with the sub-second convergence you're thinking about? The reason why I ask this is because of the fact that, admittedly, I'm a CLI girl living in a GUI world. And I swear I'm going to come up with, if anyone can actually come up with, if anyone's creative, because me, even though you think I'm creative when I'm presenting, not so much. This is just me. I would really love to come up with a little thing there, But anyway, I am a CLI girl, and GUIs and I don't necessarily get along too well. It's because of how I learn. I am not necessarily good with memorization and regurgitation. So the problem that I have with GUIs is I have a hard time remembering what things to click on and where they are. And I've been burned a lot with things getting moved around. Like suddenly something that I know of is someplace else. So the CLI doesn't really change as much as the GUI. But we're moving into a GUI world. That's just the truth, okay? So I have been using, how many people are familiar with live action? Okay, so I've been playing in the IWAN environment. I'm going to be doing IWAN for like the next 6 months. I haven't done one technology for over 15 years, but I'm going to for 6 months. And so I've been looking at the live action, and the interesting thing is that the live action, I have some net flow and some NBAR set up. And then I have some polling that goes back to the live action. And the live action basically will let me know, did I go this way or did I go that way? Okay, so it's a GUI representation of what's going on in the network. Kind of cool. Anyway. Did I go this way or did I go that way? But in my IWAN, with my policies can be so fast, I can actually move over sub-second. But it takes a while for my monitoring tool to reflect that. So then the question becomes, can your monitoring tools keep up with this? If you want really, really low, fast convergence, can your processes keep up with this? Your applications, what if you have a false positive and you tear something down and bring it up over here? Are your applications TCP? Do they tear down? Are they not TCP? What's going to happen to your applications in this environment? So I just want you to really think about this. I don't want you to just turn it on and go. You need to think about this. So it's not the same thing, but faster is not about writing protocols. It's not about failure recovery, and it's not just about one node. It's about the environment. So what is convergence? Convergence is the failure detection. So I heard that something failed, and then the event propagation, I have to go tell Ed over there. Then the routing process, I'm either going to do Dijkstra's, or I'm going to run dual, or I'm going to run the best path for BGP. We're not even going to talk about RIP. I'm not even going to ask hands to be raised for who's running RIP. I don't want to embarrass you. And then we're going to update the FIB. All of this is going to take time. So you're going to have your neighbor down. You're going to have to tell your neighbors you're going to have the RIB FIB. And so So let's just go ahead and say, what does this look like? So we actually have something happening between here and here, and then we actually lose this link right there. So you all know, right? So let's say that the traffic was actually going from A to B to D, and I lose that link. Well, first and foremost, B and D have to notice that it went down. If this is a layer 1 link, if this is one wire, it'll be pretty good. If there's a L2 VPN with a service provider in the middle or some kind of switch, then you're waiting for whatever your hello timers are for your routing protocol. So at that point in time, until A knows to go through C, it's going into the bit bucket. So the first and foremost thing that has to happen is we have to have failure detection. So B and D have to realize that the failure went down. So that is when the timer starts. The timer starts as soon as the failure happens. Can't do anything until that. Then you're going to have event propagation. D is going to tell C, my link went down. B is going to tell A, my link went down. So B tells A, D tells C. Of course, C is going to go ahead and be like, okay, well, I don't really care because you were my best path anyway. But that might not be the case. So we're going to have the event propagation or the spread the word. Then we're going to have the running of the BGP best path or OSPF, Dijkstra's algorithm, or EIGRP dual. And then we're going to decide who's best. We're going to put it in the routing information base, and then we're going to go ahead and put it in the forwarding information base. So this is all going to take time. So let's go ahead and start with the, just going to repeat this one time. Network convergence is the time needed for the traffic to be rerouted to the alternate. Just all routers. Requires all effective routers to process the event. So again, we're going to actually get into weakest link if you actually have some router in the path that actually can't handle that speed of information. So detect, propagate, process, and update the FIB. Now let's talk about the 9s. When I first saw this chart, I have been a lab rat for so many years. I saw this chart for the first time about 6 years ago. I'm like, you have got to be kidding me. Seriously? 5 9s is 5 minutes of unscheduled downtime for an entire year? 5 minutes of unscheduled downtime. It can take 5 minutes for you all to even realize that the failure happened. Okay, so measuring fast convergence, these are your 9s. This is the bar. This is the bar that potentially your management is setting, but not necessarily giving you the budget or the resources and all to actually reach. What I have noticed over the years as you all come through, and in all the years I've been doing different things in networks, so I guess 30 years now, if you're up in this area, you're reactive. You have a reactive culture. If you're in this area, you're slightly proactive, and if you're in the other area, you're predictive. So what do I mean by that? So reactive, you have few, if any, identified processes, significant number of single points of failure, low utilization. If you're in this environment, I'm just going to tell you, please address this stuff first before you try to really bring your timers down low. Because I think if you try to go to super fast convergence in this environment, especially if you don't have consistency levels with configs, because fast convergence is going to be the whole path. So I think that if you have this environment, I would start small and maybe try to address this first. If you're proactive at all, then I think you can actually start looking at this. So proactive is 3 9s and above. If you're predictive already, you already have a culture of high availability, you have consistent processes for fault configuration, performance, and security. You have no single points of failures or maybe limited single points of failures, then you are an excellent candidate to go ahead and really look at end-to-end deployment of truly sub-second fast convergence. So I'm just going to go ahead and say that because I think that if you try to do it in the other environments, they're not ideal environments, and I'm a little concerned that you might have more instability if you try to go to sub-second convergence. A couple seconds of convergence, that's one thing. Sub-second convergence, the other environments, I don't necessarily think are ideal for that. If you want to talk more about why afterwards, I'm free. So layer 1, layer 2 for failure termination, shared risk. There are 3 numbers that I want you to work backwards from. What is the longest the time could take to converge? Think about the worst place and the worst outage. What's the average time? But this is the number one. How long before applications running on the network lose their state? And are these the critical ones? Because this is the number you work backwards from. All hail the packet, all hail the application. This is what we work for. This is why we're here. How is that application going to fail? Once you know these numbers, then you can go ahead and try to go faster. Or, I know this is really strange, but when I was actually writing this slide last year, I had someone who came through the CPOC, and they were like, can we slow down this part over here? Because what ended up happening was there was actually, it was very funny, BGP was converging faster over here than something that they had going on over here. So they needed BGP, and this was not in an MPLS environment, they needed BGP to slow down. And I'm like, I have never heard anyone ask me to get BGP to slow down. But we had to slow this down because they had a whole bunch of problems over here during some failure of supervisors and line cards that they were doing, trying to figure out what the worst case scenario was. So we actually had to slow down the BGP. Yeah, I've never been asked to do that before. But that's what the application needed, because this needed to not go faster than this. And that's the other thing, right? If this one converged too fast, then the traffic over here would go suboptimal, which is not what they wanted. So they didn't want to go suboptimal. They would prefer to have the applications die than to go through that latency. Like if you have voice, you might prefer to go ahead and have your voice die and go with your branch SRST than to go over, if you lose your MPLS link, than to go over the internet link and deal with that kind of latency. Okay? So again, it's all about the application. It's not necessarily about just tuning timers. This is the mistakes for fast convergence. Let's do the same thing faster, and it's getting the routing protocol to go quicker. So I'm going to ask you to please try to get into the mindset of what is the application needs, what can you do outside the routing protocol, what can you do in the network to minimize the loss. So let's go ahead and start playing. Failure detection. OSPF, EIGRP, ISIS, BGP can't do anything in reaction until it knows that there was a failure, right? So that's where everything starts. So if you're looking to save time, there's a good possibility you might be able to save time here. So detecting the link failure. Is it easy to detect the link failure? It depends. Don't you love that? It depends. It's like the typical CCDE answer. No, I'm not serious. We kiddingly joke about that. It depends. What's the business drivers? So what you're going to have is you're going to have inside, you're going to have your hardware, you're going to have your PHY, you're going to have your port ASIC, and in software, you're going to have your CPU that's going to connect to your iOS. And then you're going to actually have these two talk to each other. So what's actually going to happen is the hardware is going to detect that you had the link down, and then it's going to report up, typically. So the interesting thing is on some platforms, so hence it depends, and some platforms are going to go ahead and go faster than others. So quick question, if I really want really fast convergence at layer 1, do I do RJ45 or do I do fiber? Why? Doesn't have to worry about bouncy. I liked that. That was good. You can run UDLD. So if you, when you actually get into it, so when we have financials come through, they'll actually tend to do fiber. They'll tend to do fiber, and they'll tend to do some special stuff in there. They might actually be doing some stuff in the middle that actually is going to go ahead and take care of rerouting around or whatever. So polling versus interrupt driven. Okay? So if I ask you, hi, how are you doing? This is a poll. I have to wait for you to give me an answer. And you can't tell me, hi, I'm doing fine, until I ask you. Interrupt driven would be Daniel being like, hi, I'm doing fine. Oh, okay, thank you. Hi, I'm down. Okay. Are you down or are you up? That's polling. So from that perspective, like the 6748 GETX is a polled environment. Okay, we poll each of them. Nexus 7K, 9K, the 6708, not the 6704, but the 6708 is interrupt driven. So it's going to be, I'm down. Now, of course, that's going to end up happening. It's going to get into, I don't know, prices, which is really great. But of course, polled versus interrupt. Now, of course, from this perspective over here, there's also debounce timers. So it throttles the down notifications. This is switches only. By the way, you really can't change this. So this is more informational, just so you know about it. Carrier delay. Who has tweaked your carrier delay in your environment? Of course you have, Daniel. So carrier delay. Daniel's brilliant, by the way. He doesn't need this class. Carrier delay. It's going to actually say when you're with your layer 1, it's going to throttle up and down and it's routers only. So this is just something for you to think about. So debounce timers, it's not always configurable. The recommendation is leave it unchanged. But just know that there is this debounce timer that can happen, the bouncy-wouncy thing, right? So there's this debounce timer, and it's going to be, so if you're looking for 200 milliseconds or less, you really have to start doing the math on everything, right? It was interesting because a while ago, last year, when the Nexus 3K came out, that was going for like the high-frequency trading stuff, and they had this like nanosecond hyper warp drive thing where they said that they could actually do the switching inside of the Nexus 3K at this like microsecond level. So I was going to test it. And so I'm like, oh, okay, I'm going to test it. And I'm just going to go ahead and tell you that, I'm not a layer 1 person. Okay, just going to go ahead and say that right now. So for those of you who kind of sort of, as soon as I tell you this, decide you're not going to listen to the rest of it, I'm really good at like layer 3, okay? So cut me some slack. So I take the Spirent traffic generators. We use a Spirent traffic generator, and I go ahead and I put a 40 gig. I put an optic in, so I have the Spirent traffic generator. So I have an optic here. I have a cable, optic into the Nexus 3K. Then of course it's going to go through the Nexus 3K, optic, cable, optic. And I am not in any way, shape, or form seeing the kind of stuff that I was expecting. And someone said, well, in like that really nice, sweet thing, well, yeah, but you have the optics and the cable. What do you mean? Well, it's marketing numbers. It's what they can do inside of the switch once it actually comes in from this port to going out to this port. Seriously? So it was kind of cool because I actually look up on the internet that an optic, a specific optic, has a range of how much time. So it's certified. It's like, okay, if you have this optic at this speed, then I should be able to take packets and go and do the optical to electrical conversion in this much time frame. And then it's going to go on the wire, and then it's going to go to the other optic, and again, that has that. So I'm adding things up. And then once I added things up for a range, then I got down to where they were. So I will tell you that from a high-frequency trading perspective, and I'm not going to have you all raise your hands, but if you're high-frequency trading, if you are a bank, you already know this because you've already sat down and worked out all of the math to get to 200 milliseconds. Why? Because 100 milliseconds to you is actually direct money. And your management supports that proactive approach. Carrier delay. When do I decide something's down, right? So in iOS XE, I might have carrier delay that waits 2 seconds to see that it's down. Of course, that's polled, interrupt, whatever. So Nexus is 100 milliseconds, SVI only. ASR, 9K, XR, nothing, no delay, right? Service provider grade. So if you're looking at iOS or iOS XE, you might want to go ahead and say, if it goes down, go down immediately. If you detect light down, if you detect something down, say that it's down. Now, what you might want to do then is delay it on the up so that you're not hurting yourself too much. So react on the down fast and then give it a little bit of delay on the up. You can also get into, does anyone do event dampening? I mean, not event dampening, interface dampening. So interface dampening is, because the first thing, of course, you're going to ask me is, okay, well, why am I doing this? Well, you're doing it so that you notice the down earlier, but then you're protecting yourself on the up. Why? Because it might flap. Well, yeah, but fish, then I wait for 2 seconds, and then if it comes up, then I'm up, and then I tear down again. So if you have physical interfaces that are bouncing, disgusting, potentially and I've heard a lot of people who might have challenges in more rural areas around, and other types of countries or more rural areas where the quality of the connection is not so good. Then you might want to actually think about what is called interface dampening. It's kind of like, has anyone heard of the BGP dampening? Where, I'm like, here's a prefix, and your service provider might do this. It's like, hi, I'm here. Hi, I'm gone. Hi, I'm here. Hi, I'm gone. And in BGP, a lot about BGP is going to be protecting itself. So it's going to be a lot about, I'm not going to let you as a service provider impact what I'm doing to me as a service provider or my CPU. Thank you very much. So once you keep on changing your mind, I'm here, I'm gone, I'm here, I'm gone. I'm like, okay, that's it, forget it. Okay, I'm not listening to you for like 30 minutes or whatever I feel like saying. And then that's it. So you can go ahead and do that, but this is carrier delay. So if you're in a data center and you want to go ahead and go with more aggressive timers, and you can see right here that iOS XE, and I'm going to go ahead and jump on something right now and tell you something that is not something that I've read or anything like that. So let's look at this. iOS XE is 2 seconds. Nexus is 100 milliseconds. So then the question is, why is iOS XE 2 seconds? Any guesses? It's older. Okay? Really, it's older. And as we get older, we slow down. No, I'm sorry. It's older. I never know what I'm going to say sometimes. So let me ask you just a serious question. And I really do. It is in my DNA to help customers. I absolutely adore you all. I really do. And I love teaching and I love learning. I love Geeks Without Borders. If you had a code version and the carrier delay by default was 2 seconds, and then you upgraded to the next main train code version, and we changed the carrier delay because we wanted to help you to 100 milliseconds as a default. Oh, can you just imagine? Okay, so we love you, and it's because we love you, we don't want to annoy the crap out of you, because I think we do that enough sometimes, that iOS and iOS XE have legacy timers in them. They have legacy timers in them because they were around, iOS was around, and iOS XE was built off of iOS so that you didn't have to do some kind of major changes as you went over there with your configs, because a lot of people are changing their iOS boxes to iOS XE boxes. So they tried to have them be timer compatible. The iOS was around when we had single brain routers and when 10 gig was just unheard of. Okay? Frame relay and dirty links and all kinds of other things. So it was, and the CPU was not as high. We didn't have applications that demanded this kind of fast convergence. So the good news is for you that have iOS or iOS XE, you can go home and be a hero. So if I were you, what number would I pick? Would I pick 100 milliseconds to go from 2 seconds to 100 milliseconds? Or would I have you go from 2 seconds to 0? I'd probably play it safe and think to myself, okay, I'm not a service provider environment. I don't need that kind of zero. Service providers pay a lot of money for those links. So I want to know when it goes down immediately. And they're big pipe links. But I don't necessarily think that you need 2 seconds, especially if you're in one data, like a data center, or this is your route reflector or whatever. So, but I wouldn't necessarily go down to 0, but maybe go down to like 1 second, or maybe go ahead and do the 0.2. So I have the recommendation here as 0.2, but I don't mean for this to be the recommendation on your wide area networks. I mean this more when you really kind of sort of control both ends. One physical cable. You have one physical cable, and that's the kind of outage you're going to have. You're going to have your debounce, you're going to have your carry delay, so we're still looking at like major sub-second, right? Assuming that you take the 2 seconds for iOS and iOS XE. So we're looking at, we can get it down to major sub-second. But what if you actually have this? What if these 2 routers that have a layer 3 adjacency are actually across an L2 bridge network? L2 VPNs, anyone know if you're doing L2 VPNs? Yep. So basically, if you have a router at one site and a router at another site, and you have the same subnet between the two of them, they're like OSPF neighbors or EIGRP neighbors, yes, congratulations, you're doing L2 VPNs. Somebody is actually, and you're not really connected to yourself, you're connected to a service provider. Because it's not really like years ago where they're going to just go ahead and nail you up a frame relay connection anymore. You know, and so have it be that. They're going to go ahead and they're going to put you in their MPLS network. The service provider is going to go ahead and put you in an MPLS network, and they're going to L2 VPN you across. DWDM without loss propagation, or tunnels, GRE, IPsec. So then in this environment, you can't just deal with just the layer 1 down detection. So now we get into what? How do we detect that the other side went away? Fast hellos. Well, hellos in general. Polled is going to be slower. Interrupt is going to be faster. So all IGPs and BGP, EIGRP, OSPF, and ISIS use hellos to maintain adjacencies. Hopefully this is not a surprise to you all. Okay, so we're actually talking to each other, and I do an OSPF hello every now and again, an EIGRP hello. And so I want to work across some L2 VPN, or it's just in my lab environment, and I've got router, switch, router. That's not uncommon that I will do that as I'm learning something new or playing in the lab, because I'll put a sniffer trace right here because I love sniffer traces. So I'll put a sniffer trace right here. So why am I not spanning? Why am I not putting something here on me to span and there on me to span? I'm lazy and I don't want to waste time. I want to know that I got everything that's actually going across, and I don't want to like miss something. So if it's going across the wire, it's going through you. So I'm going to put the span port there. I've been with Cisco for a very, very long time. So many years ago, I sometimes would get burned that the local span was not giving me everything. Or I was missing the headers that I needed because of the order of operation of where the span was. And I was missing critical information that I wanted, like the MPLS label or something. And so I'm going to put something in the middle there. So that tends to happen with me. And so if we fail the link that's between this switch and you, then wonderful. You have layer 1 down detection, and you go ahead and pull the OSPF neighbor down, and you route around the failure. Meanwhile, I'm still going, hi. Are you there? And typically it's 3 times you're out, right? So that's OSPF, EIGRP, BGP. So you've routed around, but I haven't, because I have not seen that we've had the failure detection go down yet. So hello timers can be tuned down. We call them fast hellos when you tune them down, and you don't go with the defaults. So you can tune them down, and it's interesting because with BGP, who knows the timers for BGP? Off the top of your head, yes? 1 minute and 3 minutes. Right, I of course picked that one, and you're like, oh my gosh, oh, that was a perfect face for it. It's like, oh. Right, 1 minute and 3 minutes. So 1 minute and 3 minutes. So obviously that is big. Now, the reason for that is that especially with an IBGP neighbor, the assumption is, again, high on the food chain. I don't necessarily want to have, I might want my IBGP to route around. So I may not want to put it down because my IBGP peer may be way over there through this IGP. So the IGP is going to do fast convergence, and then he and I are going to help everyone get out to the internet. So if there is some kind of churn over here, I may not want to do 1 and 3, right? Because I might actually have a false positive, and then I don't hear from him with 1 and 3, and I tear it down. So again, picking where you want to go. I wouldn't necessarily, if it was IBGP, I wouldn't necessarily have, and it was IGP is right here, I wouldn't necessarily tune it down to 1 and 3 for IBGP. I wouldn't at all, actually, between me and a router way over there. Okay, I'm gonna have my IGP tuned down, and I'm gonna prioritize my 32s in the network so that if there's a convergence, we can prioritize the 32s to go faster. And BGP will use next hop tracking or address tracking filter. And so I just know that I need to get to him, and no matter what happens, sooner or later I'm going to go over and get to him. So this does not scale well. Do it to a large number of neighbors. So if you have tons and tons of neighbors and you are doing BGP and you're doing an IGP, so some people will actually do, so a lot of you probably have HSRP, right? So think access, and you got what, 100 VLANs there? So you got like access, 100 VLANs, and you're doing your HSRP timers, and you don't want to go with 9 seconds. Okay, so you do what, 1 and 3 on 100 VLANs. Okay, so hellos are actually created by the main brain in the router. They are created by the main brain in the router, so they're process switched. So we're getting back again to the processing abilities of the boxes that you're using. So you can have high CPU. I can be a router that's a BGP route reflector, and I can have 200 BGP peers. We may not want my 200 BGP peers to have timers of 1 and 3. Okay? I actually did have a route reflector where the service provider was the ASR 1000. We had 200 BGP peers, IBGP, and it was a route reflector. And we had 2 million VPN v4 routes. That was really cool, actually. And there was like a nerd knob that you could put over on the ASR 1000. I love nerd knobs because then I feel like so cool. And that it actually doesn't put it into the rib because the route reflector is just off there as a brain. Yes, sir? So the advertisement interval, and we're going to get into that. So the question is, what about the advertisement interval with BGP? And we are going to actually get into that. So hold tight. Okay, cool. So we need another solution. So if I have PIM neighbored with you, and I have MPLS LDP neighbored with you, and I have OSPF, and maybe I also have BGP over there. But let's just have PIM and MPLS and LDP. So, and I've got lots of physical interfaces. So I'm like, on all of these interfaces right here, I have MPLS, PIM, and OSPF. And if I'm trying to do fast hellos, then on this one physical interface, if I have all of those down to like 1 and 3, which is not sub-second, but it would still be viewed potentially as fast hellos, so I would do 1 and 3, then I have to process switch. I have to actually say hello, send it to you. You have to pick it up, and I have to do it 3 times. OSPF, MPLS, LDP, and PIM. What if I could just put Daniel like right here? Okay, so we'll have Daniel bidirectional forwarding detection. Distributed bidirectional forwarding detection. So what Daniel's job is going to do is he's going to go ahead and he's going to hop in. We're going to miniaturize him. We're going to put him on the ASIC. Okay, so on a different brain. And then all he's going to do is do one of the 2 forms of BFD, bidirectional forwarding detection, because all I care about from a PIM perspective or a LDP perspective or an OSPF perspective is the link up or is it down? Do I have my peer? Can I get all the way to the other end? So I guess it's not just link up, link down. So from that perspective, I'm here, the switch is there, you're over there. Okay? I want to know, and it's kind of sort of like a UDLD, but for routing. So I want to send a BFD, so I send a little BFD, bidirectional forwarding detection thing, and there's two different modes for it, there's echo and non-echo. And then it gets to you, and even if you don't support BFD, I can actually send it to myself. So at least I can figure it out, even if you don't want to know. So I can actually send it out and then kind of come back. And so if you are not there, the BFD hello will not come back. Okay? Now, PIM and OSPF and LDP register with our little miniaturized Daniel on the ASIC. And they say, please let us know if there's a problem getting over there. And so they become what are called clients. So when you do BFD commands, you'll see that OSPF, LDP, or whoever you configure as a client is interested in having that triggered information up to them. So you don't have to go with aggressive fast hellos. So that's BFD. So BFD is, in this situation, so with BFD, failure can be detected in less than a second. So fast hellos, they're normal hellos, but fast. You can get to about a second of detection, but your process is going to actually have to do all those hellos. Your CPU, your main CPU. It's process driven, one hello per protocol. So if you have on that physical interface PIM and LDP and OSPF, that is the CPU doing that multiple times. So handled by the main CPU. BFD, it is even faster, like 50 times 3 or 150 milliseconds detection. Now, of course, again, you don't want a false positive, so you don't want to go too aggressive. So I would, you need to be able to get through that switch, over to you, and then back again. And then 3 strikes, you're out. So it is going to be very keen to your environment as well. Event-driven, it's like Ceph. One hello to rule them all. So it just goes and it checks it out there, and then, again, it tells the clients that are interested. So I don't have to do the process switching. I don't have to do the processed hellos. And actually, as you go to different device platforms, it's actually possible on hardware, some hardware platforms like the Nexus 7K, the next ASR 1000, 9000. I don't necessarily know about the Nexus 9K because I didn't look before. I forgot to look on this. But we are obviously, and all vendors are obviously trying to make our line cards more and more intelligent. So we're trying to put little mini brains down there, right? So that we can actually have a packet come in and go out. So we can actually put the miniaturized Daniel bidirectional forwarding detective kind of sort of agent down here on this intelligent line card and then just walk away. Nothing happens on the CPU. The intelligent line card itself handles it. So, failure detection. We talked about layer 1, we talked about BFD, we talked about fast hellos. If you use BFD in a typical environment, especially in your data center or whatever, I'm pretty comfortable with 50 times 3. Again, your WAN might be a completely different environment. So please don't go rushing home and put this on your wide area networks. Yes, sir? I'm sorry, sir? I'm afraid to come back because of the bundled Ethernet. So I think that actually BFD can also do, so the question is about BFD with bundled Ethernet. I know BFD can do multi-hop now in some situations. I'm not too sure about bundled Ethernet. Donnie, do you know about bundled Ethernet? I think in some platforms it can do it.
Yeah, some do it, but what they do is they send a hello down each one of the lanes.
That's what I thought they did, yeah. Right, okay, thank you. So on some platforms, so bundled Ethernet, right, would be like if I have, let's just make life really simple. I have 2 links, and I have an Ethernet port channel here. So I want to go ahead and I have, again, Troy's going to be the switch. So I have a switch. So I have a port channel over here, and I have a port channel over there. And so I want to see if I can actually get through. So with the bundled Ethernet, what Donnie was saying on some products, so just come up to us afterwards. We can figure out for your product what's supported and not supported and how they implement it and what it might or might not do for you. XR has it and 9K has it, not a surprise, because I think that's where I actually played with it, but I don't know how they do it and what number I would say to use. Okay, OSPF. When I came up with these slides, I went searching out on the internet to try to find something as a general reference. I have no idea who this person is, except that apparently he worked at I&E in 2009. Do you know who this person is? Okay, Daniel knows who the person is. So if you want his autograph, then ask Daniel. Okay. For this, especially for you with iOS, I want you to go back in time with me. So we're going to go back in time with CPUs that were not as powerful. We're going to go back in time to an environment that was more flapping and more problems. Okay? So let's talk about SPF and LSA generation throttling. So throttling, okay, is the general process of slowing down responses. So what I'm going to tell you right now is if you have iOS or iOS XE, you have legacy timers there. And we are still throttling at those legacy timers because this is what happened in the past, and this was what was done, and this was why. Because back then we did have frequently oscillating events. Right? You had, what is it, the media with the AUI, and it goes in, and then somebody hits the little media thing, and yeah, didn't you love that one? Yeah, that was fun. For all of you younger people, you're like, what are you talking about? Okay, imagine twin acts and it connected to a box. No. So we had, there was a lot more churn. Things were not as solid in the past. So what would happen is I would protect myself from things flapping over there. So you would send me an LSA, a link state advertisement, and you would say, something's here. Okay, it's not here. Okay, it's here. Okay, it's not here. Because you have a physical WAN connection over there that is just going up and down and up and down and up and down. And apparently, we have designed our network for us to tell everyone in the world about that every time it happens. Okay? So at some point in time, I'm going to be like, you know what? This is my guess. My guess is that if that's flapping, the other side of that is also flapping. So I might be hearing about this same event over in this direction as well. So I'm going to kind of sort of wait until these oscillating events that are happening kind of sort of get queued up, and I get the final report. I'm not going to go race over and chase after everything. So we're actually going to slow it down. So that's throttling. So the general idea is to reduce resource wastage, because if you tell me it's up, then I go ahead and if I run immediately, let's say OSPF, I immediately run Dijkstra's algorithm, believing you. And then I go and I tell all my neighbors, okay? So I accepted what you said. I ran SPF best path. And then based on that, well, actually, I took your LSA, and then I advertised it to everybody else because everyone gets the LSA. So I took it, and I advertised it to 12 different people. And then I went ahead and run best path, and then I forwarded based on the rib. And then a split second later, you tell me it's gone. Well, it's gone. Okay? This was the world we were living in before. So these are the legacy timers that you're going to be looking at when you're looking at OSPF. So the general idea was to reduce resource wastage, the wastage of my CPU, the wastage of my time, my CPU cycles, and the bandwidth of these links and the wastage of CPU and the clock cycles on everyone else as well. Okay? Because that was the environment that we lived in until everything calms down. So the idea was as follows. When an event occurs, do not respond to it immediately. So when you tell me don't respond to it immediately, I will respond, react. Don't take the LSA and then go tell everyone. because there's a possibility that I want to collect all of the information about what's going on first and then go bother everybody with it. Tracking? So back then, this could potentially save a lot of resources by reducing the number of SPF runs or the amount of LSAs flooded. Now, this was 2009. And even here, he's telling you this could potentially save a lot of resources. We don't have expectations of applications in the 2009 level anymore at all. So for those of you running OSPF, the biggest thing you're going to get out of this is you get to go home and tune timers, and you get to act like you really, really know this stuff. Is really cool. And I'm going to tell you some timers that aren't that bad. So this is the big hooah for you OSPF people. The question is, how long should we wait? What if I told you that OSPF waits, that iOS XE, actually, for those of you who don't, so if you know, don't mention it. Who runs OSPF? Who has not tuned these timers? Okay. I'm going to pick on the youngin'. Okay. How long should I wait when you send me an LSA? They don't make young people these days. He's like, I don't know. I think I partied too much last night. 5 seconds. 5 seconds. Okay? So if you advertise that LSA to me, iOS will throttle by 5 seconds. I will not tell anyone. 5 seconds is not going to get you to sub-second. Okay? And let's just think about that. 5 seconds is not going to get that one over there to 5 seconds. Okay? So, those of you running iOS and iOS XE and you haven't tuned these timers, you can immediately go home and show how the value of Cisco Live works in your network. So, OSPF convergence timers. You have failure detection, you have event propagation. So, neighbor down, we're going to go ahead either the timers or BFD. If you can, if it's working, use BFD. Next one, event propagation. So we're going to have two things. We're going to have the LSA generation throttle and the LSA generation tuning. And then SPF throttle and SPF tuning. Because LSA is me telling everyone else, SPF is me acting on what you told me. So the initial LSA generation delay. So this is, well, let me just show you what the numbers are. There's the initial that you told me the first time. So that LSA, everything's been fine, and then you tell me it went down. When we throttle, when we tune timers, it is common to go ahead and react faster to you telling me the first time. Then when you keep changing your mind, then I might not react so fast. Okay? That's from an LSA propagation perspective as well as an SPF perspective of me actually running Shore's path and Dijkstra's algorithm on the LSAs that you're telling me about. So we'll just go ahead and get to the numbers. So here's iOS. iOS, if you do a show IP OSPF and you can go into your network right now if you don't have anything else to do. So you can go into your network and you can do a show IP OSPF in iOS. And you can actually see this is your processor, and this right here is your initial SPF schedule delay. So this is your initial delay. So I'm going to go ahead and I'm going to get the LSAs, and after I get the LSAs, I'm going to wait 5 seconds before I then change my rib, if it changed my rib. Okay? Minimum LSA interval, 5 seconds. So you advertise something to me, I'm going to wait 5 seconds before I run Dijkstra's algorithm on it, wait 5 seconds before I tell anyone else about it. Okay? And this is the ones that are minimum hold time between 2 consecutive. So when you start telling me it's up, it's down, it's up, it's down, yes, I'm still going to tell you, go ahead and respond quickly to the first one. And then as you flap, then I'm not going to trust you so much. You know, fool me once, shame on you. Fool me twice, shame on me. So protect yourself after the first one. iOS XE, same numbers. iOS XR, aggressive numbers. Oh, I almost backed right into you, so sorry. Kind of would have been fun, though. Initial LSA throttle. So this is the initial LSA delay, which is 5/100ths of a second. Service providers would like to know quickly. Okay? Now, I'm probably not, as a service provider, OSPF peering with you as another service provider. This is my own administrative domain because I trust myself. Okay? You not so much, so my BGP timers might be different. But my OSPF, I want it to go quickly. So with XR, these are the default timers here, the initial SPF delay and the initial LSA delay. So I use this as an example of when you're trying to think of what you might want to do in your environment for iOS or iOS XE, from 5 seconds to what's kind of sort of safe. Well, XR chose this, that's 5/100ths of a second, but they still said, you know, if you're flapping, 5 seconds. If you're flapping, 5 seconds. So I do like the, if you're flapping, 5 or 10 seconds. Nexus. It actually went with a don't wait, which was interesting because the Nexus actually went with a don't wait at all. XR went with 5/100ths of a second, which I thought was interesting. And then they also went with 0.2 of a second up here. But again, 5 seconds, 5 seconds. So from that perspective, this is kind of sort of, you know, this is the wild side. If you want to go really crazy, you know, maybe you can kind of sort of take a little bit of Nexus and a little bit of XR. Again, this is your administrative domain. I would not do this with the customer. Okay? This is what you control. I would say a nice and easy start would be you start at like 5 milliseconds. General theory for timing tool is react immediately to the first one and then wait significant periods of time for the subsequent. But for those of you who run OSPF, this is huge. We have a lot of people who are moving over from maybe something with an iOS over to like a Nexus in a data center. Or 7600s as MPLS PE routers to 9Ks. And you can shave substantial times off of convergence, but again, then you can also converge too quickly for your MPLS labels. So again, think about it. EIGRP. Yes, sir? Would I recommend the values for OSPF v3? Yes, I would. And I am, and I adore IPv6. So yes. Now, well, okay. How stable is your v6? Just coming online, so it's really super stable then. Thanks for playing. Actually, that's very exciting. I'm a huge fan of IPv6. I adore it. Yes, Ed?
What about tweaking the timers? So when you're saying over the administrative domain that you control, you would not tweak those if you're running, say, across the layer 2 VPN?
Oh, so the question was, when I said the administrative domain which I control, would I not then run those timers over an L2 VPN? Yes, I would, because of the fact that they're just the pipe to get me to the other side. So if it's an L2 VPN, they're just a pipe to get me to the other side. So you on the other side of my pipe reporting to me a new LSA or whatever, your control plane is telling me that. And so they're just the pipe, so yes, I still would. I mean more like I wouldn't, I'm a little wary. For those of you who are public sector, you tend to run as your own service provider. And so it's like, okay, well, we're going to have the DMV come online over here, and we're going to have this come online over here and this, and then giving them OSPF, and then tuning your timers down so that a device that you do not control, that is not within your administrative domain, hurting your CPU and causing churn because you are extending trust to them. And that's what you're doing, right? When you tune the timers down low, you are extending trust to them. So make sure that they're trustworthy before you do that. If you just want your pager to go off because you're trying to get more money for Christmas, don't do that. EIGRP. So, for those of you running EIGRP, who is already bounding your query domain? Okay, so, bounding your query domain. Let's talk about EIGRP because I really like EIGRP, but we made it too simple for you so you don't have to think. So event propagation in EIGRP, if these are all EIGRP and router A loses this interface right here, then EIGRP will go ahead. The good is there's immediate event notification. There's no delay on any of the different platforms. There's an immediate event notification. We send out a query, an EIGRP query. And we're going to go ahead and we're going to query B. Hey, do you know how to get here? Because I used to be able to get there via C. And then B is going to go ahead and say, well, do I know how to get there? Oh, maybe you know how to get there. And it's going to go ahead and it's going to go to its neighbor. Okay? So what's going to happen is then it's going to go from B to D and then D and so on. So when you just put that network statement on, I ask you, you ask you, you ask you, and so on and so on and so on down the line, and then we go backwards. Oh, I have no idea. Dun, 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 dun. Has anyone ever heard of a stuck in active? Okay. Now, we've done actually a lot of, well, I haven't, but Cisco's done a lot of coding to actually get into a situation where, and that's one of the beautiful things actually about EIGRP is, admittedly, we can just go ahead and decide that something's the right thing to do and do it, which is kind of cool. So there's a lot of protection mechanisms. If you do EIGRP, I would strongly recommend Donnie, have you taught yet? You are teaching design and deploy with EIGRP. So Donnie is teaching EIGRP deployment 8 o'clock tomorrow. Man, your SGM just doesn't like you, does she? And then at 10 a.m., Steve Moore is teaching troubleshooting EIGRP. So I know at least those sessions both are actually tomorrow. And so if you are running EIGRP, they can talk to you about some additional things to do and talk to you about your networks. But this is EIGRP, so it's the good, the bad. Now what I'm going to tell you is that I'm going to tell you to reduce with EIGRP. So I already gave something for the OSPF people. So for the EIGRP people, I'm going to tell you, reduce the size of your query domain. Okay? So that when I go, hey, query, do you have this? Then you either have a summary or you are who has their spokes as a stub network. Okay? So if you're running EIGRP, which is very common in hub and spoke environments, extremely good at it too, you make your branch routers stubs because you don't want to use them as transits and you don't want to query them, because you're not going to go through them to get to the other subnet anyway. You don't want to. So that's one of the beautiful things about making them a stub, is you're not going to query them about things. You're just not going to query them. I mean, they go down, then they pull the advertisement. You have no one to query. But if I lose my connection over here up at the core, there's no point in me querying the branch, because you don't want me to go down there to get back up to my core and be a transit. That's what you get when you do EIGRP stub. We don't query them. If you do a summary, if he does a summary towards me, I'll query him, but he has a summary in there which bounds the query domain so it won't go down, because he can definitively say, I don't know. Filters. So these are all the things about how you bound your query domain. So if you want your EIGRP to be faster convergence, query. Your query interval. Bound your query domain. Feasible successors. Who has designed their EIGRP network to already have feasible successors in it? Okay, cool. who has no idea and is running EIGRP, what a feasible, okay, yeah, I like you, you're good, huh? I'm just going to teach to him for the rest of the class. It's very positively reinforcing. So somewhere your boundary right here, or you know what, do queries, and then if you do queries, you don't even ask. I mean, if you do feasible successors, you don't even ask. Now, just to let you know, the feasible successors are actually already there. You're actually already running them if you have it in your environment to be designed that way. So the interesting thing about feasible successors is for those of you who are looking at LFA with OSPF or whatever, I'm sorry, EIGRP was already doing that. Okay? So the concept with EIGRP is, let's say that these are not equal cost paths and that I prefer this way and that this was something that had a different bandwidth or a different delay. So that's my second one. As long as I can mathematically calculate within dual that there's no way that I learned this path here through this path, then I can make that one a feasible successor so that when the primary goes down, I already have in place my little fast reroute. So EIGRP already had this in here. The issue is there's nothing that you specifically have to do if your network actually will promote a feasible successor. You just have to make sure that you've designed your network to be able to have a feasible successor. And you can actually look in your EIGRP topo table and find out if you have a feasible successor. Yes, sir? So the question is, Donnie, is there any delay? I mean, since you're right here, why not? What is the delay between going from what you have active, assuming, and I'm going to say, sir, assuming that we obviously have already noticed that a link down has occurred. So taking that out of play, how fast is it to go from the active to your feasible successor that is already there?
Well, it depends on which one technology the new stuff we added in. You've got people stuff around. In the olden days, this is back in the 7,200 days, that's 2,500, around 50 milliseconds roughly. It's from notification of interfacing with your feed, you lost route, re-enter feed, look it up in the Google database, put it in the RIP. So it's the speed it takes to do that API call to RIP install. And then it's also, then the other pieces come in, pushing it down to the fib, and you've got line parsers and line parsers. So you're still talking 100, 150 milliseconds full time. With something like IPFRR, which is brand new, you go from 50 down to closer to 10.
So the answer was, for those of you who couldn't hear, back in the old days, even on like the 7200s and the older router platforms, you're looking at, assuming that you already have event detection, you're looking at 50 milliseconds, so you already know it's gone, because you don't have to rerun dual, because it's already there waiting. Okay, we already know, we've already pre-calculated it. So we already have the feasible successor. So, I'm sorry, you didn't say 50 milliseconds, you said? Yeah, okay, you did say 50. So 50 milliseconds. And then there is additional stuff coming online, like IPFRR, IP fast reroute. Who's heard of IP fast reroute? Okay. Luc Dejean has a session specifically just on IP fast reroute. I think he's actually already taught it, but again, all of the videos come online within 4 to 5 weeks. And it's completely free whether or not you came to Cisco Live or not, the breakout sessions, not the labs and the technical seminars. So if you're interested in that, again, please don't do that if you're only at 2 nines or 3 nines. Please only look at IP fast reroute if you got everything else already going and you've already done some, because you're looking at 10 milliseconds then, potentially. And again, is that really what you want? So I have 0. That was bad, and easy. So this is just explaining what feasible successor was. I used to have this as a hidden slide, but I had enough people not knowing what feasible successor was, so it's unhidden now. So this is basically Do I have something that I can mathematically prove that I didn't learn through the other best path? If I do have something I can mathematically prove is not a recursive lookup, then it is a waiting there, ready to go ahead and just be put into the rib and the fib. While I'm talking about this, I am going to quickly say, for those of you who are EIGRP, please, 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 never use bandwidth to try to influence, okay? So please use the delay metric to engineer your EIGRP routing, not bandwidth. Does anyone actually, so bandwidth is a pretty big stick, right, for EIGRP. It really forces it one way or the other. Now, I will say that I have done it before on loopbacks when I have, like with Anycast RP on a loopback. But why wouldn't you not do bandwidth on EIGRP? Well, it is like an atomic bomb, except a little bit less painful, depending on your management. Hmm? So many other things are affected. Good answer. Okay. And then use this one next time for the next question. No. So many other things are actually affected. So did you know that EIGRP was actually designed that if we had, because I want you to go back in time again, right? So we're going to go back in time again together. So I have a link, and the bandwidth of the link is, we're going back in time, 10 meg, right? The bandwidth of the link is 10 meg. So what I want to do is I want to make sure that the traffic going across, it actually gets across, and EIGRP doesn't like eat up everything. So the bandwidth of your physical interface will be the bandwidth that I use that will throttle me to not going over 50% of the bandwidth. Really, really fun when you get to like those, kilobit things, okay? So please be really, really, really careful with the use of bandwidth because it actually has other impact other than just engineering your routing. BGP. BGP is not really fast. Okay? It really, I mean, it is, but it isn't. So for those of you who are using BGP in your enterprise network, you're probably doing it. I absolutely adore BGP. I got a little sticker on my laptop, BGP Geek. I love BGP. Taught it on Sunday. BGP to me is extremely powerful. Who's heard of eVPNs and VXLAN and all that kind of fun stuff? Yeah. Okay. BGP, IPv4 address families, IPv6, VPNv4, VPNv6, IPv4 MDT, IPv6 MDT, MBGP, L2 VPNs, VPLS, EVPN. And I also really have to admit that as somebody who likes troubleshooting, I adore the fact, honestly, that it's TCP-based. I use that because if I'm IBGP'd way over to him over there, IBGP, and I have some problem in my network, I'm looking typically for something that has TCP in it because guaranteed delivery, so I can actually use the network to help me figure out what's going on. And because I will actually have whether or not, so if we have a problem between you and I, we will actually tear the session down. If I can't guarantee the delivery, I'll tear the session down. That's a clue. I can do a show TCP over here or show BGP neighbors, and I can actually see how many out of orders, how many retransmissions, what's my round trip average. Okay, so BGP is not a sports car. It never was meant to be a sports car. BGP to me is more like an 18-wheeler where I can put lots of boxes in it, and I can shove in those boxes IPv4 and IPv6 and VPNv4 and VPNv6. And that other thing I was telling you about, because it's not the IPv4 routing table that's the biggest challenge for service providers from what I understand. It's the VPNv4. Okay? When I said before 2 million routes, that ASR 1000 with the 200 BGP peers and the 2 million routes, some of you might have been thinking, well, what the heck was that about? The routing table is, the internet routing table is not that big. This was VPNv4. This was a service provider trying to test out to make sure this ASR 1000 could go ahead and be a route reflector in their VPNv4 network when they're offering you all L3 VPNs. And you've got network 10, and you've got network 10, and you've got network 10, and we have duplicate networks, and I don't feel as a service provider buying one box just for you, and one box just for you, and one box just for you so that you all can use duplicate networks. And I have to make sure, of course, that your traffic doesn't go into his, otherwise you're going to want money back. Okay? So it is meant to be a workhorse. It will keep working when every other IGP would have rolled over and begged for mercy. That is its role. If you're trying to use it as an IGP for fast convergence, I'd like to see your network, because I think that there's another way that we could potentially do that so you're using the right tool available to you. So BGP is not IGP. It has different goals, lots of data. BGP was meant to, I actually met someone the other day who actually saw the napkins, the BGP napkins. I'm like, oh my gosh, I just want to touch you. I want to see the napkins. So, it was the BGP napkin, it was the napkin protocol. And it was, how do we have traffic in the internet? How do I, as a service provider, communicate with you? How do we do this in the internet? How do we have this thing called BGP? So it's a lot of CPU, it's a lot of work, because what's going to happen with BGP, which is very interesting, is I, as a service provider, can be connected to many other service providers. And all of you are going to have a view of some subnet that's way over there. So I'm going to have in BGP what's called multiple paths. And you're going to advertise to me your best path, and you're going to advertise to me your best path, and you're going to advertise to me your best path, and you're going to advertise to me your best path. So I'm going to have all of these. So I have a lot in my BGP table to go through to make a decision. That is not going to be the case in your IGP. So you need control plane workhorses, you need CPU, you need memory. So, and also, as I was saying before, BGP generally rides on top of your IGP. Now, obviously not when you're connecting to your service provider, because typically your service provider connection, your eBGP service provider connection, is a point-to-point, typically. But in your environment with iBGP, again, it's probably that my iBGP peer is, I might have two over here, we're in New York, and then I might have two over in Chicago where I have another access or something like that. So I'm going to be relying on trying to get to my 32. So that makes the 32 very popular. I'm trying to get to my loopback. So how fast your BGP can go ahead and do some reconvergence will be very reliant upon your IGP. It's very high on the food chain. So if we have iBGP here, as I said, you have iBGP, and then you have IGP here, you can see how the logical iBGP peer, which is not tied to a physical interface, it is not tied to a physical interface. The default BGP timers are going to be 60, 180, 1 minute, 3 minutes. This is your environment. If this is iBGP, this is your environment. Please have your IGPs converge below 60 seconds. Okay? I just need the 32. I'm probably using the loopback here and the loopback here. I just need that 32. I just need that 32. I need that to be working. I don't care which way I'm doing it. So if you're doing iBGP, really, really look at your IGP. And there's little events versus big events. A route flap someplace with BGP versus, and the convergence versus you doing a clear IP BGP. Now, some people do admittedly think that if they do a clear IP BGP, what they have done is they have tested in their environment how long it would take for everything to come back up. You really necessarily haven't. If you really want to test that, that's actually what we did. We had that 1000, ASR 1000, we powered it off, we powered it back on, we timed it. Okay? For actually bringing everything back up from the ground, because other people weren't like, oh, I was right in the middle of TCP with you and blah, 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 blah. So I want you to think about data plane versus control plane. So the keep alives are 6180. I say don't tune here, and the reason why I say don't tune is because I would I'm really referring here to your iBGP, and I'm really referring here to the BGP, the iBGP in your enterprise. I want the BGP timers to be such that we don't tear that down because we didn't survive your IGP outage. So that's what I mean about I wouldn't necessarily, if I was BGP peered, I would not BGP peer with you and do 1 in 3 seconds. I would not BGP peer with you and do 3 in 9 seconds. Okay? Because as soon as I lose you, then everything I learned from you, I'm going to withdraw from my BGP table. And I'm going to send withdrawals to everybody else that I knew about. So I'm going to go ahead and I want the IGP to converge, and I want our iBGP to go ahead and just be based on letting that converge. Now, we're going to talk about something that BGP does, which I also like, but if you do summarization, it can cause some problems. You can do fall over BFD. Please be really careful when you actually try to do BGP aggressively. BGP is much different than IGPs. You're going to use BGP differently in your network than your network than your network. So please don't just rush out. I have told you go rush out and change some of your OSPF, go rush out and bound your query domain. For BGP, do not go rush out and do anything, okay? Because one size does not fit all here. BGP is very versatile. You're all using it in different ways. Interface tracking actually notifies BGP if the interface or the route goes down. So this was years and years and years ago. It was called the address tracking filter or address tracking feature, or ATF. And then we actually had next hop tracking on NHT. Who's ever seen the heard about? I mean, if you're older, you had the BGP scanner, right? It was like every 60 seconds. I'm going to go ahead, yeah. And you actually would go through the BGP table, and then you would actually scan through the entire BGP table to make sure that the next hop for every single solitary bloody thing in there was still in your IGP. And so you would see aliases, or I would see aliases that were like CPU, BGP scanner, or, bad convergence, 60 seconds convergence, because the BGP scan timer years ago was 60 seconds. And so you could wait a really long time to find out things. So then back then, people would go ahead and, if they could, they would reduce their BGP scan timer. And what I mean by that is if their CPU could handle going through the table, and you didn't have a lot of churn, you didn't have a lot of stuff. So if you could handle it, you would probably reduce your BGP scan timer. Because back then, if you had a single brain, your CPU, single brain routers were also the ones that you could just do a show proc CPU on. And if a packet was coming in and was going out, you could just see it in the CPU. Because either it was process switched, so it made it to the first number. So if you have like 97/60, then your CPU in general is at 97%. 60% of it is interrupt, and 37% then means that it's is processes. But you could see back in the day, it's so much easier to troubleshoot, you could see back in the day everything. So you would reduce scan time. People also back then would, because of the fact that their IGPs were not as stable or the environments were not as stable, they would tune their BGP timers. So you might still find some old documentation having you tune BGP timers because the scan time would take so long, so you would actually go ahead and tear down your BGP session faster. That's not today. So today, what actually happens is that if I'm connected to, I'm connected to Marvin. So Marvin and I are BGP peered, and we actually have a switch in between. So we're going through Luis. So we've got a switch in between. Actually, we'll make you a router. Have a router that's going on between. And if that link over there goes down, and this is layer 3, and I'm going to his loopback, and let's just say for grins and giggles, I just have Luis. So it's just the three of us. So me as a router, Luis as a router, and Marvin as a router. If that physical link goes down over there, and that's why I'm saying have your IGP actually work this out. If that goes down over there, then you will hopefully be tuned with your IGP to detect that that 32 went down on his loopback because that was your neighbor. So you're doing BFD or it was a physical link, it's down. You're tuned with your LSA, your SPF, whatever, to tell me immediately. As soon as I notice in my rib, because I have this ATF, this address tracking filter, so or feature, I always get that messed up. So when my BGP came up with you, I said, oh, take this 32 and little code in here, ATF, NHT, next hop tracking. Track this next hop for me in the rib. And if it goes away, then I know I should tear down because I don't have a way to get to you. So I can go ahead and tear down and not have to wait for the timers to pop. Now, what happens if he's also advertising to me a quad 0, a default route, or a summary? Okay, well then I might think that I can still get there. So again, things to think about. So BGP convergence tunings have different focuses. With BGP, you're probably going to go to seconds or minutes. Okay? You can get it to seconds. Minutes is because of the fact that you have the BGP timers to realize that the other one has been gone. You can't use ATF and HT because there's no way you cannot send a default. So I can't do ATF and HT to tear it down. And I can't do BFD, so I have to do BGP timers. And I'm a router that I can't do 1.3. Now here's the interesting thing. So if I do a BGP timer 1.3 and you talk to a service provider, so I talk to you and I do BGP timers 1.3. So I say, hello. And then it's like, okay, hello. So what happens is if I want to go ahead and do timers of 1 and 3, poor Jim here, I'm going to say hello and you're going to say hello back. So basically what wins is whoever's lowest. So he can say that he wants to do BGP timers 60, 180. But as soon as I say I want to do timers 1.3, he's going to go ahead and he's going to respond to my hello. So basically we're doing 1.3. Your service provider may say, yeah, you may want to, but I'm not going to. So they may actually have on there something like 10, 30, so 10 every 10 seconds instead of 60, 10, 30, 30, which means that the minimum hold time that they will do, that they will allow you to bother them with little hellos, is 30 seconds. If you try to come in with a 1.3, they will not actually peer with you. You will get a BGP notification that you have unacceptable hold timers. Okay? So if you're peering with somebody else, or if they're peering with you, if you're peering with a customer and you don't do that, you might actually you're doing 1 and 3 and you don't realize it. You're configured for 60 180s, but you're doing 1.3. So again, extending trust. So initial convergence with BGP is limited by the amount of work that needs to be done, how quickly the router can do it. BGP is admittedly much more complicated when you're trying to think of convergence. Again, I'm sorry about this, but all of you are going to use this differently. So it really depends on the number of routes, the number of peers. Are you doing IPv4? Are you doing VPN-v4? What are you doing it for? Are you on top of your IGP? All this stuff really, really goes into play. For those of you who are interested in some BGP classes, there is, and I happen to know this one off the top of my head, it's BRK RST 2044, which has to do with BGP and multi-homing. So if you're actually having problems trying to split, like you want to use this one versus this one, there's a BGP multi-homing one. It was already on yesterday. If you can't wait 5 weeks, then you can go online today. And the speaker for that actually couldn't make it to Milan, so it's me. So I taught that one in Milan. And so that's the reason why I know that it's Michael Cole, he's fantastic, really good slides. Also, troubleshooting BGP was completely done new this year. So again, BGP is not going to be a one-size-fits-all. So event propagation, you're going to have a lot of issues with convergence, because what's going to happen is I may have a lot of information for you. So it's not necessarily, again, even with BGP, about tuning timers. Because if I have a lot of information coming from him that things have changed, then I have to tell you. And he's typically not going to tell me that just one thing changed. Now, he might. One issue that I'll just say real quick that I tend to notice is even on aliases, even right now, high CPU in BGP. Most of the time that turns out to be you doing a wide open redistribution of your IGP into your BGP in your own internal network. So what you're doing is you're saying, I do not want to bound my failure domains. And this is a design decision. My traffic is so critical. I don't want to use a BGP network statement. I don't want to do a summary. I don't want to do whatever, because as soon as you do that kind of summarization, then you can have suboptimal routing. So you may have a design decision that you want to redistribute your IGP into your BGP. And as soon as you do that, what you're saying is every time something flaps over here, especially if you go to more aggressive OSPF timers or whatever, and that's why I want you to think this through. If you have OSPF now and you go from 5 seconds in your iOS and your iOS XE, and you bring that down, and you're redistributing your OSPF into BGP, you're not just going to feel it in your OSPF world, you're going to go ahead and you're going to feel it in your BGP world. Because the increased chattiness over there is going to go ahead and go over here. So that's one of the big things that I see is it's kind of like, oh, we're just going to change OSPF here. Well, no, but you're also doing this with BGP. So with BGP, you're going to have TCP, you're going to have the default MSS as 536 of how much it can actually go in there. You're going to have that I have a lot of information to send. It's not just prefixes. I have a lot of attributes. I have next hops. I have communities. Got a lot of stuff in each one. And BGP, again, is a big container, so it might be a big 18-wheeler with a lot of stuff to bring. And you don't have your hold queue set up properly, your input hold queues, your output hold queues, especially at your route reflector, because your route reflector is going to talk to lots of people at one time. A lot of hellos, TCP, SYN, SYNAX. So again, BGP is going to be a little bit harder. So you're going to be looking at MTU, you're going to be looking at BGPs, you're going to be trying to get your MSS up. You might be doing jumbo frames. Your local TCP buffer, your ACKs, your hold queue, all these things are going to impact how fast you converge. This is the scanner I was telling you about. This is old and busted. The next hop tracking is the new hotness. It's really not that new. It's been around for a while. It's already happening. You don't even realize it's happening. But this is the reason why your scanner is not going crazy anymore. It's event-driven. We like event-driven. And it's keyed off of your IGP metric or path change. So basically what happens, and you don't even realize again that you're doing this either, is that you have 3 subnets, 10.1.1.0, 10.1.2.0, 10.1.3.0, and they all have the same next hop. Cool. I'll take that next hop. I'll tell the ATF and HT, track this for me. Let me know if it changes, event-driven. So then if that changes, then we go ahead and we just say, okay, I'm going to go ahead and do this. I'm going to do one next hop. So we change the way that the table is actually done and read, because this is illogical. So then actually, if that next hop changes, then the pointer, everyone just does a pointer to something. So for those of you who've been around with BGP for a while, and you've been noticing that your BGP scan timers are not having high CPU, and you're having faster convergence with your BGP and all this other stuff, yeah, okay, you can continue to think it was you. So it's a single change, multiple entries, convergence independent timer, and you can go ahead and try to even tune it even more. Okay, MRAI, minimum route advertisement interval. Is anyone here a service provider? Okay. I'm so sorry. I'll point him out to you and I'll hold him. No, I'm kidding. Minimum route advertisement interval. So let's go again into the service provider world where they want very much to protect their resources from churn and crap. Okay, remember I said that service providers have a lot of different paths to get to the exact same place. So before, when he was sending me the LSA and it was going up and it was going down, it was going up and it was going down, I'm like, yeah, at some point in time. So if I'm autonomous system 14, you're autonomous system 15, you're autonomous system 16. We are eBGP peered with each other. We'll look in the service provider world first. So if I tell you that something just changed, okay, then again, what did I say? The first time I tell you, you'll go ahead and act on it. So he'll go ahead and tell him. Now something happens a second later. Do you think service providers really want to do this? I have lots of best paths. Okay? I've got one in there. You're probably not my only way to get there. Okay? So as long as I'm getting there, I'm getting there. It might not be the best, but it's working and it's stable. So what's going to happen, and the reason why this is relevant for you all if you're enterprise customers, because he was already nodding his head, service providers already know about this. So the reason why it's relevant is I asked you before how many people were running BGP in your enterprise, within your enterprise. Now, some of you are actually doing eBGP within your enterprise. Many of you are, especially the larger enterprise customers. If you're public sector, you're doing this also, and you're segmenting out the different areas because you've become a small service provider for end users, DMVPN, this college, whatever. So here's what happens. There is a minimum route advertisement interval. And you were the one who asked me the question, right? There is the minimum route advertisement interval. And it is not a trivial size. Who knows what the minimum route advertisement interval is between eBGP neighbors? 30 seconds. 30 seconds? Okay, we'll look at it. What about for iBGP peers? Actually, it's 0. And I am thrilled to know the person who coded that. So Daniel Walton, BGP, so a number of years ago when it changed, because they both had the same MRI, it was like, well, it's iBGP. It's our administrative domain. We'll set it to 0, and if we don't like it, we can adjust that. So with iBGP, it's 0. With eBGP, oh great, now I'm messed up. I want to say it's actually bigger than 30. I want to, for whatever reason, I want to say it's 60. I want to say it's 60. So I want to say it's 60. But what it is it is again a throttling. And you have to think about the service provider environment. All of you are telling me about X. It's up, it's down, it's up, it's down. Okay, that's it. I'm not. So if you think about it, and we're going to have each of you be an eBGP, so I advertise something to you. So each of you are eBGP. You advertise it to him, you advertise it to him, you advertise it to him, but let's say the environment was completely stable, so you do that immediately. Okay? And now he advertises something to you, it's changed. You would like to tell that peer about it, but you have to wait for the minimum route advertisement interval to pop before you can tell him about the next change. So if you're doing eBGPs in your network and segmenting things out, data center or small service provider or whatever, if you're having delay and you have a very linear environment where you have eBGP this, eBGP this, eBGP this, and you're going hop by hop, and if you have churn, especially if you're doing my favorite thing, which is you're redistributing your IGP into your BGP, especially if it's wide open. So that's going to be a lot of I have to tell you things, and then I have to wait for the timer to pop again. I tell you something, I have to wait for the timer to pop again. Okay? So that minimum route advertisement interval is going to impact you in an eBGP environment in your own environment, especially if you are multiple eBGP segmentations. 30. You were right the first time. I knew it was on the next slide. So IBGP is now 0. eBGP is 30. You can change this, no problem. The pros is it promotes stability by batching the route changes together. So again, getting back to the whole concept of if something happened, something else might happen also, especially from an eBGP perspective, because if all of you can get to path X, then the problem might have been over there. And I might actually hear from all of you that you have a new BGP best path change. So instead of me going this way, every time you all tell me, I'm going to go ahead and batch it together and then send it. Very proper in a service provider world. Okay? Improves update packing in some situations. Update packing is when you have a change to tell me, you have a change to tell me, you have a change to tell me, and I go ahead and I gather all of those changes, I pack them all together, shove it into whatever my TCP packet is, and I can send it across. The cons is, of course, it may drastically slow convergence. 30 seconds, 30 seconds, 30 seconds, 30 seconds. If you have autonomous system 1, 2, 3, 4, 5. So this is the MRA. So this may take several rounds of exchanges. The MRA must expire between each round. So additional routed convergence. So we've talked about your OSPF, your EAGRP, how it gets into your routing table and your BGP, how it gets into your routing table. Then it goes ahead and it gets into your forwarding information base. Now we're going to talk real quick about the timing of this. So this, we've gotten it down to, maybe you get it down to like 10 milliseconds if you're really, really, really going for wicked, wicked fast. And all the stars align, you can get it down to this. Now remember, you still had to get your down detection going. And you have to do with that EIGRP, you have to do the IP fast reroute to get down to 10 milliseconds. Okay, with OSPF, you have to go with really horrible, itty-bitty, I'm not going to wait a second, 0 timers on the LSA. So in order to get down to this number, which is possible, especially if you're trying to be a financial and you're already at 4 or 5 nines. If you're not, please don't try to get down to this number. Whoops-a-daisy. Oh, I thought I had. Oh, goodness gracious. Okay. I think I have another slide that talks about, unless I accidentally made it hidden, that talks about going from the FIB, the forwarding information base, down to pushing it down to an intelligent line card is very platform dependent as to how long that takes. Obviously, ASR 9K, things like that are going to take a lot faster because that's the environment they're built into. And all of this is not just us, this is every vendor. So software theft updates. How you can do stuff, of course, is going to be based on how fast your brain can think. Just like your laptop. Just like anything. So your supervisor is going to matter. We were talking before about the processes and your supervisors and the workload. So your supervisors are going to matter, especially if you have tons and tons and tons of routes like with BGP. That's why the ASR people had, like for the BGP route reflectors, it used to be like the 7200, now it's like the ASR 1000 because it's a control plane workhorse. I would not make a BGP route reflector an RSP 720. Right? So this is the RP1, this is the RP2, RSP2, I'm so sorry. This is the RP2, so the RP2 is actually in the ASR 1000. It is a control plane workhorse. It is meant to be a control plane workhorse. So supervisors matter. Your rib size is going to matter as to what your convergence is. So I'm going to tell you, if you can, if you're really looking for some tweaks, you've got the OSPF, you've got those timers, EIGRP, bound your query domain, BGP. You got to learn a little bit more about BGP and figure out what you're trying to do with it. There is one other thing with iOS and iOS XE. You can actually do OSPF prefix suppression. And you can also do this one right here, prefix prioritization. This is beautiful when you're running BGP or when you're running MPLS LDP. okay? Because all you care about is quickly, if you're label switching in your environment, okay? If you're label switching in your environment, and I've got all of these devices here, and you and I are IBGP peered, and I've got MPLS between us, then, and if I'm running VPN v4s, I don't care about your 10.1 or your 10.1 or your 10.1 because you're all labels in the middle. So I don't care about what I need is when this changes, I need the loopbacks to get installed quickly on the /32s. I need our BGP loopbacks because hopefully your MPLS, you've actually made that /32s on your loopbacks for your router IDs. I need my BGP to come up fast. So when you're really looking at how do you get it really granular, okay, there are different other things that you can tweak as well, especially if you're a financial. If you're a financial, you probably already know all this, though. Which protocols support that? Actually, it's really more what platforms support this. You can do this both with OSPF, ISIS, and EIGRP. I don't think you can with RIP. I'm so sorry. Yeah. But it's really what platforms. So this can be 1 to 5, going from here to here. That's the most aggressive you can get down to, and this is very platform dependent. This also has to do with your TCAM. What kind of memory is it? Is it easy? Is it fast to read from, but slow to write to? Right? I mean, componentry matters. BGP pick. This is the wave that I'm doing. Ready? Wave. BGP pick. So it's protocol prefix independent convergence. If you're heavily into BGP and you're really looking for saving some timers, you can look at BGP Edge and some more complex BGP pick. And then there were LFAs. LFAs are loop-free alternates. So EIGRP obviously had a loop-free alternate. We mathematically calculated that. You can do that with OSPF. And then actually you can do it with OSPF and you can do it with ISIS. It'll calculate the second best next hop, what EIGRP has already been doing for a while. And it does not work in all topologies. It's the same as EIGRP. It won't work in all topologies if I cannot mathematically prove out that the second one is not actually dependent on the first one. If I can't mathematically prove that out, then I can't necessarily put it in as a fast reroute option. Non-stop forwarding and graceful restart. This is just a flyby. The slides are really for you. Non-stop forwarding, graceful restart. The only thing that I'm going to tell you about this is do not do fast hellos and NSF, non-stop forwarding, graceful restart at the same time. They are two different designs. Route around the failure or route through the failure. Please take your pick. Okay? Non-stop forwarding means that I have two brains. You have one brain. I'm sorry, you're the customer. Oh no, I'm going to die, I forgot. I have two brains. You have one brain. So I have two brains. I have one active. I have one hot standby ready to take over. Okay? So what he and I are going to do is he and I are going to lie. What we're going to do is we're going to go ahead and say we both support the graceful restart bit, whether it's OSPF, EIGRP, MPLS, LDP, BGP, we're going to support the graceful restart bit so that when my primary dies, that what we basically do is we go ahead and I have to go back to him when my primary dies and I have to say, can you send me everything all over again? Now, normally, if he wasn't in on the lie, he would be like, yeah, that's it, we're tearing you down. But he's in on the lie, so he goes ahead and he continues to forward traffic to me, hold the traffics in stale. NSR, and I just tossed these in, actually, they're just there for you. We're basically done. This is the end. NSR, wouldn't it be cool if my two brains, if you didn't even have to configure, you didn't have to be in on the lie. You could just be just sitting there, right? You could just be, innocent, so you don't have to be in on the lie. So what happens is, and this is supported, like, for example, with the XR platform, again, it's nonstop routing. The other one's nonstop forwarding. So your routing, our peer goes down because we had to, reset, especially if it's BGP because it was based on TCP. So our peer goes down, it comes back up, but you continue to forward the traffic to me based on what I told you last. Nonstop routing, our peer never even goes down because I take care of it myself. I was wondering how they were going to do that with BGP. I'm like, oh, I wonder what they're going to do because I heard it was going to come out. Are they going to like have the active, how much memory is that going to take? The active is going to have to keep on telling the standby what my TCP windows are and everything. You know what they did? Packet comes into the fabric, it gets sent to the active and the standby. Yeah, that was probably smart. So that's what you do with BGP NSR. Nonstop routing, you don't have to be part of the lie. You never see the BGP peer go down. However, if you did fast hellos and my other brain was not up yet, then you would route around me. So if you have your timers below what I can do to have my other brain come up, so do not do that. It's a design decision. Route around or